the discriminant. The discriminant is the part of the quadratic formula underneath the square root symbol. It's b squared minus 4ac. It tells us whether there are two solutions, one solution, or no solutions to a quadratic equation. The equation must be written in standard form, which is ax squared plus bx plus c, where a, b, and c are real numbers. Let's find the discriminant of example 1. So if we look over here, I'm going to highlight these coefficients in orange. That's going to be my a. Purple, that'll be my b. And green, oh, I should also say, it's positive, and that's green is my c. So let's see. So b squared. So b, that's my whoops. Let's go again. That's my purple. And then a, that is my orange. And c, that's my green. All right. So b squared will be positive 5 squared minus 4 times a. Oh, I should have done this here. A is 3. B is positive 5. And c is 1. Sorry about that. I put those there for a reason, and then I totally forgot about them. All right. A is 3. So I'm just filling in this equation right here with these values. And then c is 1. And so in this situation, I have 5 squared, that's 25, minus 4 times 3 times 1. Well, 4 times 3 is 12, times 1 is 12. So that equals 13. So in this case, we have a discriminant of 13. So when the value of the discriminant is 0, there will be one rational solution. One rational. Rational means that it can be represented as a fraction. So one solution, and that solution could be a whole number, but it's also could be a fraction. Let's see, and the next one is going to be a positive one. So if the solution is a positive perfect square, if you don't know what the square numbers are, 1 because it's 1 squared, 4 because it's 2 squared, 9 because it's 3 squared, 16, 25, 36, 49, 64, 91, 100, and so on. In that case, there will be 2 rational solutions. The next possibility is a, let's see, a positive integer, not a perfect square. So a positive integer like 3 is not a perfect square, 2 is not a perfect square, 5. So all the things that are perfect squares, take them out of the positive integers, which are like the positive counting numbers. And in that case, you're going to have 2 irrational solutions. So whereas a rational number can be represented as a fraction, irrational numbers cannot. And so they're going to be like square root of 3, square root of 7. So it's going to involve a square root. And lastly, if the discriminant is negative, then in that case, there will be 2 complex solutions. So a solution involving complex numbers or imaginary numbers. All right, we're going to practice finding the discriminant now. Remember, it's b squared minus 4ac. So in this case, b squared, negative 17 squared, minus 4 times a is 4, times c is 3. And I think I'm going to need a calculator to do that. So give me just a second to pull up a calculator. All right, so let's see, we have 17 or negative 17. It doesn't matter. When we square it, it's positive. So 17 squared minus 4 times 4 times 3, that equals 241. So in that case, is 241 a perfect square? Let's do the square root of it, because that's what, whoops, so clear, whoops. So square root 241, and that is not a perfect square. So this, we can look up here. This is a positive integer, not a perfect square. So we have two irrational solutions. So in this case, two irrational solutions. Great. All right, here, b squared, so my b is negative 2, and minus 4 times AC. A is negative 2, that's this one right there, and C is 3. So let's see, that's going to be 4 plus 8 times 3. I just did the negative 4 times negative 2. 4 plus 24 is 28. That is not a perfect square. So again, two irrational solutions. And uh-oh, this one doesn't equal 0. Don't worry, we just add 9 to both sides. We get negative, and that's a negative 1, x squared plus 6x minus 9 equals 0. So again, it's a b squared, so 6 squared minus 4 times a times c. That's going to be 36 plus 4 times negative 9. 36 minus 36 is equal to 0. Oh, so there's a different one. So in this case, 0 says there will be one rational solution. So here, one rational solution. All right. Some quadratics are also known as trinomials, will always have a discriminant equal to 0, like we saw in that last one. Those are known as perfect square trinomials. Perfect square trinomials. These quadratics occur when we multiply a binomial by itself, like in example 5. So in example 5, the trinomial that we create when we multiply this binomial by itself, the binomial is x plus 3, will be a perfect square trinomial. So I'm going to use FOIL here. So firsts is x squared, outers 3x, inners 3x, lasts 9. If you don't know how to FOIL or you want to review, I do have a video about foiling. It's just called FOIL. So this is x squared plus 6x plus 9. So this is a perfect square trinomial. And it's a perfect square trinomial because we created it by squaring a binomial. All right. It can be useful to know the pattern all of these kinds of trinomials follow, but it's a little complex. The general form, so a and b are just numbers, is ax squared plus or minus, one or the other, 2 times a times b times x plus b squared. So a and b are the coefficient and the constant in the binomial ax plus or minus b squared. So if we have a subtraction here, then this is subtraction. If we have addition here, this is addition. So we're going to look at the general cases over here to see why this turns out to be true. Okay, so remember that this is ax plus b times the quantity ax plus b. Firsts ax times ax is a squared x squared plus, first outers, ax times b is abx. We can rearrange the order of multiplication. Inners, b times ax is abx. And last, b times b is b squared. And now we can combine these two terms right here. So we get a squared x squared plus 2abx plus b squared. So the perfect square trinomial that results from this binomial squared is like that. And it's a little complex, I'm not going to lie. So on the next one, again, we have the binomial ax minus b times the binomial ax minus b. And here it's really just the same. First, sorry about that. Ax times ax is a squared x squared. That's firsts. Outers is a negative b times ax. So that's negative abx, reorganizing the multiplication. Negative b times ax is negative abx, reorganizing the multiplication. And negative b times negative b is positive b squared. Now we're going to combine these two terms right here because they both are x terms. And we have a squared x squared minus 2 times abx plus b squared. And you can see that in both of those cases there, what we have is really this right here that we mentioned. So let's look at a real example now with those are examples, but an example with numbers for the coefficient and the constant a and b. And so we have the quantity negative 2x plus 5 times the quantity negative 2x plus 5. And we're going to FOIL firsts. Negative 2x times negative 2x is positive 4x squared. Outers, negative 2x times 5 is negative 10x. Inners, 5 times negative 2x is negative 10x. Lasts, positive 5 times positive 5 is positive 25. When we combine those terms, we have 4x squared minus 20x plus 25. So now what we can see is that when we look at this right here, we're in a case where we had a negative 2x as our leading coefficient, and that resulted in a negative here. So what we have is our a is 4. So that means that this negative 20 is going to be negative 2 times 5 times the 2, the leading 2. So 2 times a times b, 2 times a times b is going to be negative 20. And then b, 5 is 25. So if you look at the square root of this and the square, it's kind of complex to see these, but you get the hang of it the more you see them. And if you don't get it right off, that's okay. Just know that they exist. All right, that is the discriminant.